So in this lecture, we will see the elementary signal transformations. So we are going to discuss 3 transformations. The first one is time shifting. Second is time reversal. And finally, time scaling. So we will see each of these in detail. So first we will see time shifting. So this simply means that we are shifting the signal on the time axis. So there are 2 ways in which you can shift on the time axis. Okay. So let us take a signal x of t with respect to time, right? Now let us say we have a signal something like this. Okay. So now this is t is equal to 0, right? So what we can do in time shifting is we can shift the signal either to the right side or to the left side. Okay. So if you are shifting to the left side, that means that you are making it earlier version. Okay. So this is called advanced version. If you are shifting to the right side, then that is called a delayed version of x of t. Okay. So we will see how the delayed or the advanced version of this signal will be like. So then you will get a better idea. First we will see time delay. So a time shifting is represented with x of t minus t naught. Okay. So this t naught here is the amount of time by which we are shifting the signal. So for the time delay, here the t naught is going to be greater than 0. So we will see how this looks like. On the time axis and on the y-axis, you are going to have x of t minus t naught. Okay. So now since t naught is greater than 0, it is going to lie to the right side of t is equal to 0, right? So this is t is equal to 0, t naught is positive, so it will lie somewhere here, let us say. Okay. Now what will happen? Each of the point of x of t is going to be shifted by t naught. So if you take t is equal to 0, let us say that this point here is a. That means x of 0 is equal to a. Okay. So now x of t minus t naught, if it has to be equal to a, this means that t minus t naught should be 0. So t should be equal to t naught. That means at t is equal to t naught, this particular signal is going to have a value a. Okay. So if a is here, then this is where the peak is going to lie. This peak here is going to come on to this point. Okay. So the graph is going to look like this. Okay. So it is the same graph, exact same graph. The only difference is that it is shifted by an amount of t naught. So you can see that each and every point, see, let us say this point, it was at a time which is less than 0. Here it is going to be shifted by an amount t naught. Okay. So each and every point will be shifted by an amount t naught. So this is the delayed version. Okay. Why it is called delayed version? Because here in the original signal, whatever is occurring at time 0, the same point is occurring at a later time. Okay. After time t naught. So that is why there is a delay. We see that there is a delay. Now what about advance version? When there is a time advance, then it is going to be x of t minus t naught, where t naught is less than 0. Okay. And in some books, you will also see it as x of t plus t naught, where t naught is greater than 0. Okay. So either of them is right. Both of them, they mean the same thing only. Okay. So now how will the signal look like? X of t minus t naught where t naught is less than 0, or x of t plus t naught where t naught is greater than 0. So how will the signal look like? Let us say t naught is here. Now the peak is going to occur at t naught, and what is the value of the peak? It is going to be a, right? So you're going to have a signal like this. So this is the time advanced version. Okay, so each of the point of x of t is going to be shifted to the left by an amount t naught. So it is called advanced because it is occurring earlier. Okay, so this is about time shifting. Next we have time reversal. So how is this going to look like? It is simply a reflection about the y-axis. So we will see the example, then it will be clear to you. Let us say this is x of t on the time axis. So the signal, let us take something like this. Okay, so this is x of t. Now how will x of minus t look like? So time reversal is simply x of minus t. So you can see that it's simply the reflection about this y-axis. Okay, so y is that if you take a point, let us say this point is some t1. Okay, and at t1 the value is at the peak, let us say a. Okay, so now x of minus t, when will it be equal to a? When minus t is equal to t1, that is at t is equal to minus t1. So exactly if t1 is here, on the other side you have minus t1. At this point you're going to get the peak. Okay, so in the same way, each and every point you take, it is going to be at the exact mirror reflection. Okay, so you are going to get a signal that is going to be a reflection of this signal x of t about this axis. So how will it look like? The peak is going to come here. So this is going to be like this. Okay, so this is the time reversal. And finally we have time scaling. So this is going to be either a compressed version of the original signal or an expanded version of the original signal. So we will take an example, it will become clear to you. So let us say here we have x of t and signal is going to look something like this. Now if you take x of 2t, okay, so this is the compressed version. So why it is the compressed version, we will see now. Let us say this point is t1 and this is minus t1. So we are taking a symmetric signal, okay, for ease of understanding. Symmetric signal means x of t is equal to x of minus t. You will see the same form on either side like a reflection. Okay, so for this signal, if you do time reversal, it is going to look one and the same, right? So that is what a symmetric signal is. So now we know that x of t1 is equal to x of minus t1 is equal to 0. Okay, now x of 2t if you take, if 2t should be equal to 0, this means that 2t should be equal to either t1 or minus t1. So that means t should be equal to t1 by 2 or minus t1 by 2. So the signal x of 2t is only going to occur between t1 by 2 and minus t1 by 2. Okay, so we can compare here. If this is minus t1 and this is plus t1, minus t1 by 2 is going to occur here, plus t1 by 2 will occur here. So the signal is going to occur only between minus t1 by 2 to t1 by 2. It is being compressed. Now what about an expanded version? So the expanded version is going to occur when the signal is x of t by 2. So this is the expanded version. Okay, so you can verify x of t1 is equal to x of minus t1 is equal to 0. So now if x of t by 2 should be equal to 0, this means that t by 2 should be equal to t1 or minus t1. So this will give you t is equal to 2 times of t1 or minus 2 times of t1. Okay, so if you have t1 at this point, then 2 times of this is minus t1. So 2 times of t1 is going to be like this. Okay, so now the signal is going to occur from here to here. Okay, so how will it look like? It is going to look like this. See, one thing that you have to notice here, this peak is not changing. Okay, it is remaining the same. So this is how time scaling looks like. One of the easiest ways to understand these signal transformations is by means of an audio signal or a video signal. Let's say you are watching a movie and you are running it at twice the speed. Okay, so you are fast forwarding it. Then what is that? It is time scaling compressed version. Okay, this is fast forward. Let us say you're running it at half speed. Okay, then that is going to be time scaling but an expanded version. Half speed or low speed. Okay, half speed means t by 2 you are doing. And what about time reversal? Time reversal simply means that you are playing it backward. Okay, you are rewinding. That is time reversal. Time shifting you can understand by means of a delay in your, like you are on a call, let us say. Then sometimes there is a delay in the receiving of the audio or the video signal, even on a video call, right? So that is the time shifting. Okay, so this is the practically how you can understand what the scaling, reversal or shifting means in terms of signals.